let's get going again here. So is everyone back?
Yes.
Yes.
Thank you. I did it real quick.
Poor puppy got overloaded.
Yes.
Too much information. Okay.
That's me.
So,
What is this, the glamour position?
all right. So the second segment. Let's talk about circuit assembly. Okay.
No.
All right. Here we go. All right. So circuits A and B. Okay. So here's our circuit. Here's our bellows and our water trap. All right. And here's our water chamber. Here's our caps, and here's our pressure lines. Okay. So the circuit will say do you want to B, okay, and the compatible. So on the label there. So make sure you get the A or the B. So these ones are A/Bs now.
How come we don't get the A's with the pressure lines already included?
Well, like I said, that's too expensive.
Then leave the lines on.
Because think about it, it's a waste of resources. Because when we throw the lines away, because they never touch the patient.
I agree that. Yeah. So when you guys on the adult area have the little lines, the yellow, the green, and the blue line,
Don't throw them away.
Don't throw them away. Just leave them on the
If you
machine.
can.
So the only thing that needs to be thrown away is, like I said, is the circuit.
Oh, the circuit.
But the pressure lines, because there's no patient contact, just wipe it down. Because you'd be surprised how much those things cost. If that was your home budget, all right, you'd be like, it's okay.
You can't buy extra groceries.
It's like, mommy, we're gonna recycle this because it doesn't need to be thrown away.
How come we have enough for adults, we don't have enough for the money for the kids?
Can
we answer that, or is that on another slide?
Actually, there's more money. We use more money in the meal pizza than adult side.
Sometimes they get water in them.
Oh yeah. I mean, so if they do, if the pressure lines get water, then there's a problem because water should be going back into the system.
Yeah.
Alright.
Oh, thank you, John.
Alright, okay, so here we go. So first thing you want to do is take your bellows, okay, and hook it into the notches and tight, and secure it tightly. And then after that, and then the water trap goes right down underneath. Alright, so here's your pressure lines. Okay, green for green, red for red, white for white, and blue for blue. Okay, alright. Don't do blue for red, green for blue.
Why not?
Now,
that's a good question. Why not?
No, now you can. Okay, you can do that. But here's the kicker: is that they made this color coordinated so that way you keep the lines separate from both areas. Pressure lines are pressure lines. It doesn't matter. Okay, but some people that are not comfortable with high frequency, they need this to make it easier for them. Okay, because some hospitals don't do this enough. So that's why by color coding it, it makes it kind of user friendly. We'll say those terms. User friendly. All right, caps. Okay, be gentle with these things. Always put on the outside, and it's like anything. Just make sure it's even, and then press down until you click. Okay, until it's locked in place. Do not touch the center part. Okay, because what happens is that if you hit this, you'll undo the seal, and so it'll flop around, and you'll have a big leak there. So make sure that this is tight, it's not moving, and it's evenly. Then press down until you hear a click.
And then the little check for the pillow inside, make sure it's all the way around.
Yeah. So after that, okay, then be careful with your hands. Okay, so you want to take that tubing and connect it to your bellows.
We're real busy.
So here's your bellows. Here's the outer rim. It's hard to it. All right, so that's what's safe. So you may have to work it in, but just be careful. Always try to keep the two pilot balloons upright. Okay. So after you got everything connected, you want to connect the green line to this side and blue line to this side. Okay, and your red line will come to the proximal end. So here's your oscillator. Here's the piston. Okay. So what we have here is that we have this two controls. So these are your mushroom caps. Right here. So this is what they control. The inspiratory bias flow and also your valve for your gas outlet. So this is what controls your mean. Your delta P and your hertz amplitude is all controlled by the piston, okay, and your bellows. All right, so once we have everything assembled, okay, so on the back is your bias flow gas. You have to hook it up and make sure it gets the inspiratory limb, goes over the humidifier, gets moisture, and then it goes to the patient, up through here to the patient, and a cycle through. So here's your green line to your mushroom cap, blue line here's your red line, and here's your white pressure line. Okay, so make sure everything's connected. Now here's the thing. If you were to reverse this crisscross, okay, your ventilator will not work.
That's the kicker.
Okay, your ventilator will not work. Your ventilator is going to give you some funky numbers, and it won't turn on. It won't do nothing. So that happened one time, you know, and so we're troubleshooting, you know, and so the therapist calls me and says, hey man, I can't get this thing to work, you know, and we have a patient coming in, so I go up there, take a look at it, you know, we're looking at everything looks good, you know, and next thing you know, it's like, I look down, it's like, you know, and I go, oh, okay, yeah, so I saw my eyes crisscross, like, okay. So once we undid that, everything worked, came into picture.
Was that Jerry Soldana when he was on the night shift?
No, not quite. It was pre-Jerry. All right. So after you got your circuit set up, okay. Now we need to do the patient circuit calibration test. Why we do this is because this is to make sure that we have no leaks in the circuit. So when the question is asked, why do we do this procedure? Is to make sure that we have no major leaks in the circuit. Okay. Because if we have big leaks, then we're not going to be able to achieve the high mean error pressures that we need. We're not going to be able to achieve the high amplitude settings that we need to get the patient to vibrate. So it's very, very important. So on the side of the machine, okay, this one's rubbed out there. So it's, but some of the machines has this. We have to get some new ones. It says off patient. Before use on patient, each patient circuit must be calibrated to the model 3100 by the following procedure. So this is your calibration. This is not your EST. Insert stopper at patient Y and turn on the bias flow gas. Rotate mean pressure limit, adjust controls to max. Set your bias flow at 20 liters per minute. Depress and hold the reset button while the oscillator is off. Okay. So do not start the piston. If you start the piston, then I already know that you don't know what you're doing. Observe your mean pressure displayed so that it reads 3943. So if your circuit is intact, there's no major leaks, you'll get this setting, 3943. That means that you're good to go. No major leaks. Now, micro leaks is okay. Small leaks, you're going to have small leaks. That's okay. But you'll be close. So if I do this test, okay, and I get a different setting. I say that I get like say a 36 or 35. All right. Now you can come up here and you can adjust the screw. All right, but you're cheating. Okay, you're cheating because what the screw is meant for is for the micro leaks. So if my number says 37, 38, okay, and I need to be 39, then I can come over here and turn this dial to 39, get it within specs because those are micro leaks. But if my number says 34, 35, that's a huge leak. So now when you do this, you're going to be cranking this puppy all the way clockwise until it can't go anymore. And once you can't go anymore, you can potentially strip it and ruin the ventilator for any future usage. So please don't use this for major leaks. What that major leak means is that when that number means a 35, that means that your circuit has a huge leak. So you need to troubleshoot it. So what do you got to do? Go back and here's the easiest way to do it. Disassemble and reassemble the whole thing. It's like trying to find a needle in a haystack. Okay, where's my leak? So I come over here, check this. I come over, check this, check this, check this, check this. Then I do the test all over again. Still has a leak. You didn't find it. So you turn it back off. Okay, you go back. So the easiest way to do it is that go check these lines. Okay, and if you don't feel nothing loose, just disassemble the bellows because a lot of times the bellows don't set correctly. And you may have a micro leak. Your water trap, make sure that on the bottom of the water trap that you close the valve off because air is going to leak out that way. Okay. Also, if you think your water chamber is perfect, okay, they're not. These things have cracks as well. So what you can do is that you can take this tubing and the tubing here and get a 15mm adapter and bypass your water heater, the chamber, and do your test. And all of a sudden, when you do your test, and you come within 3943, then that tells you that your water chamber is bad, so get a new water chamber. Replace it. Okay? So that's what that test is. Any questions about that? Okay? Okay, no, good. All right, good. So the micro leaks, if it's 37, 38, want to adjust your patient circuit calibration screw to 39 or 40, okay, and then you're good to go. Other part, your bias flow needs to be at 20. Okay, and remember what's more correct when we adjust the flow meter is that the ball needs to be above the line, below the line, or in the middle of the line. Okay, in the middle. Okay, that's how we set our settings. So when we set our bias flow, okay, it needs to be at 20 liters at the middle line. If it's below, that means that you don't have enough bias flow going through. So that's why your mean is not 3943. If your bias flow is too high, what's going to happen to our mean readout? It's going to be high because remember we added more flow, so more resistance, so we're going to have a higher mean because you added too much bias flow. So be careful with your bias flow. Because a lot of times that the lower pressure is because our bias flow is not in the middle. Because people think it is, but when you look at it, the ball is like below the head of the ball is below the number 20. So once you crank it up to 25 to 20 in the middle, everything works perfectly. Okay. All right. So on the top of the ventilator, okay, is our performance test. This is actually our EST. All right. You don't have to do this if you don't want to. Okay. So here it is. These machines are very reliable. I do understand, at Kaiser, so when you guys first started that you had to do the patient's calibration, this one, and also the performance test. But if your circuit doesn't pass, okay, this won't pass. Okay? If this passes, I guarantee 100% of the time, this will pass. Because all you're doing, you're just setting your values, and it's going to give you a readout, okay? And the readout's going to be 19 to 21, and 100% of the time, it always comes in play. All right? But the most important piece of this is that you have to make sure that this is calibrated. Okay? If you forget to do the performance check, don't worry about it. Okay? They always come in. So, but if you want to practice doing a performance test, well, I recommend you do. Because like I said, it's a good way to understand, how the machine operates. If you look at here, altitude, okay, as altitude changes, okay, well, guess what? Your readings will change as well, and your delta P will change. Okay, so because of air resistance, higher we go, there's less air resistance, so that's why our mean, our delta P will change. Okay. Any questions? All right. Okay, so adding inline oxygen analyzer. High frequency, got it added in, just because we don't have a built-in analyzer. So there's two ways to do it. Okay, so one way, on your water chamber, you put a T. Here's your bias flow gas from the back of the vent. T it in, boom, boom. Okay. Now another way here is that you see this little flow meter down here. Yeah. Okay. Now there's a blender there. Okay, and that blender has a flow meter adapter. That's actually for your ambu bag. Okay, because with the blender system and the high frequency, because we want to adjust what the patient needs. Because our NICU babies, we never give 100% gas. We always use a blender source. But because the bag and the blender are so far away from the patient, this makes it so convenient. Okay, so that way we can hook up the bag there. Now, at this facility, I noticed that we use this as our O2 analyzer. Okay? So imagine what's happening is that if we hook up this adapter with a flex tubing, okay, there, and then we turn it on to like 2-3 liters, and it's constantly bleeding out into the room. So what are we doing to the room? We're filling it with oxygen, concentrated oxygen, right? So, I mean, do we need to? Yes, no, maybe?
No.
Oh, that's a dramatic pause.
No, because the way we set it up is we put the fluid
Yeah, that's the same. But ultimately, when you turn this flow meter on continuously, what happens to the concentration of oxygen? It just leaks out to the room. Okay.
It doesn't lead to the ventilator, but the idea is it a good use of oxygen, being that it's a pressure source? Yeah. My question is, and it's a generic question. I don't know why respiratory therapy departments, you think of any department in any hospital, not just this one, there's always a shortage of O2 analyzers.
Yeah.
I think we got one in this whole department.
I know, but we have like a bucket full in the equipment room there.
Yeah.
And so that's what I'm saying, that's where they're located. And because we don't utilize it enough, you know, everyone says, oh, we're out of it, so then it just sits there and doesn't get used. So those equipment that we don't use it, they burn out, you know, because of non-usage. But I mean, the key, the thing that, my thing is that, well, if we can hook it in line, okay, and not waste, and hook my bag here so that whenever I need, I'm right there. Because the oscillator is always off to a side, you know. And before, when we used to do the straight arm in, well, it was so far away because sometimes we had to position the baby away from the wall, at the head of the board, so they're like this angle. So there's no way you're gonna reach. So that's what I'm saying. So that's why they made this flow-meter adapter on a blender, so that way you can use it as an ample back source. Okay. So, but this facility here is, a lot of staff got accustomed to hooking up a flex tubing there and measuring your analyzer. So you can do that. I mean, it's your option, but understand that you can tap it in line, and then use this as your angle back source. So whenever you need, boom, 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 turn it up out there. So you don't have to go all the way to the wall and grab. Because sometimes your O2 tubing is not long enough. Okay. All right. All right. So let's talk about the alarms. So alarms. Set max and set minimum, okay? In the NICU, 2 to 3 above. Adults, you can go 3 to 5, plus or minus 5 in adults because the ranges are so much higher, okay? A couple things here you see is that you have your science button, okay? So when the vent alarms and you know what it is, put it please and hit the science because it's such an annoying alarm and everyone's gonna look at you, ding, 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 you know, like a truck backing up, you know, like, and then the longer it goes, like, okay, hello. So to kind of, to divert away from the attention, just hit the silence, okay? All right, so your lights are going to indicate, okay, light up. So which means is that, all right, remember these are alarms that you set. Whatever value you set, okay, if the alarm hits it, that means that is a trigger point that, hey, something's wrong. So if I set my peak pressure, high pressure limit at 43, so when my mean, okay, hits 43, what's going to trip an alarm on you? Because that means that something's happened. There's an obstruction. So my high mean air pressure alarm is going off. Now, is the vent going to shut off? No. Okay. So this was a big question that that I have for people is that this is an alarm. This is not like a conventional ventilator where we set a high pressure alarm. So when the peak pressure hits that point, the vent shuts off automatically. Well, this doesn't function that way. This is just a basic alarm. If our mean hits above 43 or 43, it's going to alarm at you. But the vent will not shut off. Okay? Understand that. And I'll show you the other way we can show you how to safely set your pressure limit. Okay, minimum. If your mean air pressure falls below 14, again, it's going to chirp. As a matter of fact, if it falls below 14, it'll shut off because there's not enough pressure in the system, okay, to continue on. One thing about these oscillators is that it has to have a built-up pressure inside the system. So when we start the oscillator, we hit this and the oscillator start, you hear this like a jet engine preparing to take off. Because what it's doing is pressurizing the circuit. So allowing for the bias flow to circulate across, and so you need that. If it's too low, it'll shut off. You have these indicators here. Okay, mean air rate greater than 60. Okay, that's gonna alarm comes down here, okay, to this part here, less than 30. So what that means is that 20% of your high pressure limit alarm, whatever you set, okay, if it's too high, your vent will never start. So here's an example. Your mean's at 30. Okay, no, I'm sorry, no, that's too much. We'll say this. Your mean's at 25. You set this pressure your set max pressure alarm at 43. Okay, so 25. So we'll do the math. These are 20. 20 to 43. That's 23-point difference. Okay, your vent's not going to start because the difference from your mean and your set is so off that your ventilator's confused. It needs to be a 20% difference, otherwise it won't start. So sometimes when you see that and you hit the start, you're like, dude, it's not starting. You know, what's going on? Everyone's looking at you, come on, let's go. Okay, because this is too high. Always keep this 2 to 3 above. Okay, keep it tight. then your alarm will never ever shut off, and it'll always activate. Because that's the worst part, when you hit start and nothing happens. The moment of truth, start.
Here we go.
Okay, start. Okay, all right, please start. Okay.
Please start, please.
Because this happened, some of the competencies I performed, and like I said, and you guys did a really good job, but these are fine details, and amazing how these little fine details affects the oscillator, because it's a safety mechanism, because they don't want you to have this huge of a variance. Okay?
That's why some people max out their above and below alarms, because they think they're helping themselves.
Yep.
And actually they're initiating a problem.
So your mean here says 25. So like I said, keep it 2 to 3 above. Okay, and don't go above 20% of it. Otherwise, you'll get this potentially, and you'll get this where it's less than 5, because the pressure difference is so huge that your event won't start. And if you want to practice, when you get an oscillator, do that. Crank up the alarms, okay, and try to start it without the baby on it, and you'll be surprised that nothing will happen. But once you lower that setting down to within a reasonable rate, 20% of the sets of your mean, pops right up. You're good to go. Okay. All right. So that. Okay. The bottom 4 lights. Source gas low means that you have a drop in oxygen or air pressure from your source gas, the wall. If something's low. Oxygen is low or air is low. Okay, hopefully we'll have an O2 alarm, oxygen flow alarm buzzing, if the pressure drops below 40. Battery low. All right, so this little battery is probably the most important battery that you ever own or operate. In the back of the ventilator, okay, in the housing, you unscrew this, two screws. There's a little 9-volt battery. Okay. That 9-volt battery controls your power disconnect alarm. Okay? So what I mean by that is that your ventilator is hooked up to the wall. Okay? Every Wednesday morning at 6 o'clock? 6? Wednesday morning at 6? The generator backup check? Okay? So the backup generator kicks in. Alright? Now, if this wasn't working properly, you would never know that the vent shut off. Because the oscillator has no battery backup. Because it's such a huge, powerful machine that there's no battery to back it up like the Avias and the A40s. Okay? So that's why it's very important that you monitor this alarm. So when the ventilator loses power, this thing will alarm. Chirp, 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 chirp. Annoying alarm. Okay? That's what that means. That's all that means. Okay. So even though it lights up, okay, and when the ventilator is powered, it's working great. That's great. But ultimately, when you lose power, this is what's going to save you. All right. Oscillator overheated. Okay, so in the back, okay, we have this little water chamber and this outlet here. Okay, this is cold air going over the piston to cool it down. Okay, like a car, like the radiator, it keeps it cool. So cold air runs over the piston, so as the piston creates friction, heat, all right, it cools it down. If this light ever goes off, that means that your whole cooling system is broken, is malfunctioning. And if you don't stop the ventilator and change it out, what's going to happen? You'll smell overheating, and if you continue, it'll burn and blow up. Okay? So be careful about that. So if you smell something burning from the oscillator, and please, make sure that you don't ignore this. Take it out of the system. Anything from the wall is super cold, okay? Because that's where the system is generated. All right.
So for that little cup, because it'll fill up with water.
Oh yeah, this one never will. Yeah.
But on the adult one, it did.
Oh, it did. Oh,
Wow.
okay. So if you ever want to get rid of the water, underneath here is a little button.
Okay.
Push that button and the water will leak out.
What would cause it to have water?
Water in the hospital system.
Well, it's, the beads,
Condensation?
the beads in there, it's not doing its job. So that's why, because those beads are like those moisture absorbing beads. And because you don't.
Because there's a lot of condensation on that too, because it's an adult patient.
Yeah. But I'm really surprised that it will go in here, because
Yeah.
this means that the wall system has moisture in it. And that's a big concern.
That's a big concern.
Yeah, because if you look at the line,
Seriously, that's a big
this is
concern.
this is your air line.
That's it.
That'll kill all that, that'll
Yeah.
really,
So something's contaminated in the system, because you're not supposed to have moisture in the system. Yeah.
you have to notify the hospital engineer.
Yeah. So next time that happens, let me know. So that way we can inform the proper, engineering staff to go take a look at the air compressor, because something's leaking in the system and it shouldn't be. It should be dry. Now
Well,
you-
she's okay.
Now you know. Good. All right. Okay. So let's look at the difference between A and B. Okay. So the A, we have two buttons here on our limit. Okay. And we also have this piston centering adjust. Okay. Because the magnet's so small that we have to center the piston. Okay. The B. Okay. We have no piston centering. You don't have to worry about. And if you look, you don't have this limit adjust button. You only have one button to adjust your mean. Okay? Why is it that way? The B is a huge magnet, so it doesn't need to be centered. Okay? It's not that sensitive. But the A is a small magnet, so it always veers off. And so we want everything to be in line. So that's why we have to we have to center it every single time compared to auto centering here. Okay? Now, let's talk about the two buttons here. The green button says adjust. This is how you adjust your mean air pressure. Okay? This is the only way you adjust your mean air pressure. On the B, we have the adjust button. Only way to adjust the mean. Now on the A, okay, we have this blue button. Okay, this is our limit button. What this does, okay, remember we talked about on conventional ventilation, when I set my high pressure limit alarm on my alarm settings, if I set it at 30 and my patient's at 20, all of a sudden it hits 30, the peak pressure, the vent shuts off. Well, that's what this does. Okay? You set this to the point where you don't want this mean to go any higher. And so that way it will prevent the mean from going over that. Your max pressure over here is only alarm. It tells you, hey, guess what? Whatever you set, well, it hit it. But the vent will still continue to function normally. So that's why you have to set your mean pressure limit alarm.
A lot of people set those alarms the same, and
Yeah.
that's a pop-off.
Yeah.
And if you don't set that blue one on top, on the A correctly, you're gonna stifle your amplitude and you're gonna stifle your mean.
Yeah.
So it's very important you learn how to set that top limit now.
So I'm gonna talk to you about how we set this. Okay, and like I said, this is gonna be the addition that on the slides I'm gonna add some more stuff. This is gonna talk about how to do this.
I want to see the dog with the lips.
So here we go. So an easy method to do it is this way. Is that you put this on your max. Okay, just like we did for the patient circuit calibration. Okay, just max it out. You gotta control your mean with this green knob. So my mean's at 21. Okay, that's why I set it out. Now, what you're gonna do is that you're gonna turn your limit dial down. Go counterclockwise. You're gonna keep going down until you get less than 21. Your green button is at 21. That's how you set your mean. Now my limit button, I'm gonna turn it down until I get less than 21. So what's my limit now? So if this number is at 20, what's my limit?
21.
It's gonna be 20.
20. Because remember, my green knob, where it's set, is at 21. But my limit knob, okay, as I turn it down, it says 20. So where's my pressure limit?
Try this one.
20. Okay. So now what you do after that is that you want to go one more below, go to 19. So you keep this turning this to 19. So at 19, what's my limit? 19. What's my adjust button set at? 21 originally. Okay. So here we go. So now that I'm at 19, I'm going to make a small fraction of a turn. Okay. This number's going to go up to 20. I'm going to determine how much did I make that turn to make the number go up by 1 point. Okay? I'm going to do the same thing. Now that I'm at 20, I'm going to go make a small turn with my limit button to see how much turn it takes to get me to 21. Now I've guesstimated what that turn is going to represent. There's no exact science. Like I said, high frequency, it's very confusing because it's all by, random guesses, educated guesses. So by making a small fraction of a turn, I brought it to 20. I made another fraction of a turn, I made it 21. So I gauge how much of a turn do I need to make to take it to the next point. So now at 21, I make a fraction of a turn, okay, to 22. Is my readout going to say 22?
No.
Because remember, because my adjust is set at 21. So it'll never go above 21. But I constantly adjust my limit knob, so I'm guesstimating 22, 23, 24. So it's a small fraction. Okay? That's I know it's kind of crude, it's like, well, it's a guesstimation, yeah, that's what it is. So now that you've guesstimated to be about 23, okay, how do you confirm that where it's at? So what happens is that when you take your baby off to bag or suction or weigh, okay, you turn your adjust all the way to max. Your number should go no higher than 23 where you set your limit at. Okay? That's how you know, that's how you can confirm it. So next time you take the baby off, do that to see where you're at. Okay, people say, what are you doing? Oh, I'm just checking my limit, pop off where it's at. Okay, as a safety. Okay. So now, you just turn your adjust back to 21, where it's supposed to be, put the baby back on, and you're good to go. Now, the book says that this should always be at 12 o'clock. So wherever this dial is, this one should always be 12 o'clock. Now, if this dial is on 1 o'clock, 2 o'clock, like the face of a clock, well then this should be at 2, 3 o'clock, okay, to be safely. But you'll notice that your adjust will never be on the 1, 2 o'clock side. It'll always be around 10, 11, maybe noon on the clock window. And to keep it safely, just past noon, okay? And it'll always keep you within that 20 range. Now, Ron was asking, how do you set bias flow? Okay, so remember what Ron said about the bias flow? That we turn the bias flow down to 15, right? Okay, then we adjust our mean down. Okay, and you can also adjust your limit down too, to wherever you want it. So now after you set your mean limit, now you can turn your bias flow up to no matter what, and it'll never go above that point. Are you going to remember that? All right, that's what I'm saying. That's what certain things, if you don't do it on a regular basis, it's confusing. Okay, you forget, and that's why to me it's like by doing it this way here, it's easy to remember because now you're still doing it safely with the patient on the vent because you're never exposing them to too much because you control your mean here, you drop this down below your mean, then you crank it up a little bit at a time to see how much of a turn it takes to make that turn, make that point go up by 1. And you kind of guesstimate those turns. So you want 2 or 3 above? Well, that's what you said at 23. You said this at 23. So when this alarms, that should shut off at 23. It shouldn't go any higher than 23. Okay? Like I said, and I'll have this, in the additional slides for the handout for you guys, so you guys don't have to worry about it. All right. The main point is I want you guys to focus on the material here. Okay? Sometimes when you guys write too much, you get distracted. All right, so we got that one down. All right. So next question: how do we set optimal mean?
Here we go. Okay.
Okay. Because the whole presentation was on optimal mean. How do we get to that point? Remember, the vent doesn't have any graphics. Okay. All you hear is and you see numbered readouts. Okay. So where are we at? So this is what we do. Number 1. You determine what the mean is on your patient on conventional ventilation. So let's say the patient has a mean of 19 on conventional ventilation. You want to go 2 to 3 above. So always be conservative. Okay. Same thing with adults. Adults, they say you can go 3 to 5 above, but if you just keep it one way, be consistent, you're fine. So if you go 2 above your conventional mean, so I'm going to start my oscillator at 21. Okay. I'm going to dial that in automatically. Now I can take the patient and hook them up to a high frequency. You already have your hertz set preset. Okay, so let's say this. Let's say we're 50-50. So for the neonatal side, all right. Actually, so we'll say neopete. Okay, so you set your baby. This the pediatric kid, big kid. We'll set it at 6. Okay, so big 16, 17-year-old kid. Adults, You know, like I said, we can set this 3 to 5, like we did. So you preset that. You set your mean at 21. The amplitude, you wait, okay? As a default, you can set it at 30, 40. That's a default. It's no big deal. You put your patient on the high frequency. That's at 21. This is at 6. Now you're gonna crank this amplitude up. Okay? When do you stop?
For the big kid, when the weight go at the time.
Okay, so thank you. So one thing I didn't mention is that for babies, we talked about the appropriate, the chest wiggle is from the nipple line to the umbilicus. Well, adults and pediatrics is from the nipple line to the thighs. Why we do the thighs? Because remember, they have a lot of resistance, a lot of body fat, you know, stuff like that. So the thighs means that the lower lobes are participating in the ventilation process, and that's what we need to ensure that. All right. There was a tip someone said that they will put a pen or pencil on the thighs. If that jiggles, then that means that we have appropriate. Okay. So because sometimes when you look at it, you can't see the skin because there's too much fatty tissues. But sometimes when you put a pen or pencil and you see that thing move, then you know that you're getting proper movement. So how do you set it? Again, you just keep going up. Don't stop. Keep going up. You know, until you see the thighs jiggle. Now, after we set this, okay, we'll say this patient needed 43 to get proper chest wiggle because that's your ventilation process. That's what's going to move the CO2. Okay. Now we're going to hit the optimal mean. Now, in the lecture we talked about is that we said that in order to ventilate and oxygenate properly, what do we have to have? So in order to ventilate properly, appropriately, what do we need to ensure that the patient has on the high frequency?
Alveolar ventilation.
The optimum peak.
Okay, optimal peak, optimal mean. If you get anything from this lecture, okay, always remember that you have that optimal mean, optimal peak for the high frequency to work. Because if your lower lobes aren't expanded, open, well, then they're closed for business. Nothing's getting in, nothing's getting out. So that's why you have to ensure that your lungs are completely expanded, okay, for this machine to work properly. If you don't, then you got to change